Everybody. In this video, we're going to discuss the last topic of Chapter E, unit conversion. Okay, um, we're going to see a lot of problems involving unit conversion, and there is something I want you to pay attention to during the calculation. Okay, especially the units, how we use the units to guide us when we try to set up the equation. Okay. Um, let's take a look at the unit conversion between temperature units. Okay, the first example here, let me write it here, is between. Okay, let me write it here. It's 183.4 degree Fahrenheit to degree Celsius. Okay, as we mentioned in our previous video, the video number 1, units of measurement. Okay, there is an equation between the degree Fahrenheit and the degree Celsius. Okay, and that is degree Celsius equals to degree Fahrenheit minus 32 divided by 1.8. So what you need to do is you just need to plug this value in this equation here and do the calculation, and that's it. Okay, so let me do the calculation here quickly. So that equals to 183.4 degree Fahrenheit minus 32 divided by 1.8. Now here I have a very important thing for you to remember. Okay, when you do calculation, as we know, we need to pay enough attention to the significant figures. But if you are doing calculations involving constants, what should we do? Well, if you take a look at this equation here, okay, in theory, if this is just a pure mathematical calculation, then for the top one, since it's a subtraction, we need to consider the number with the fewer decimal places, right? This one, it's ambiguous, but we will consider that it does not have a decimal place. So for the intermediate answer of this step, it's supposed to have no decimal place. Okay, but in chemistry, okay, what we need to do is when you do calculations involving constants, you ignore the significant figures or decimal places of those constants. In other words, for the top calculation, the subtraction, since this is 32 is a constant, we should ignore the decimal place of this constant. Okay, so that tells us the intermediate answer for the top part, it's 151.4. It's just supposed to have one decimal place like this number has. Okay, because this number is supposed to be from a measurement. Okay, so we should pay attention to the decimal place or significant figures of this measurement. These constants, we ignore them. Okay, we ignore the significant figures or decimal place. All right, so we are supposed to have, let me still highlight the decimal place we are supposed to have. Okay, all right, now you still have 1.8 at the bottom. Okay, now for this step, again, 1.8 is a constant. So for this division, we should follow this number. Okay, so we ignore the significant figures of this constant. Therefore, for this calculation, it will give us 84.11 degrees Celsius. Okay, we keep 4 significant figures like this number has. All right, so this is the example A. Now example B, let's do the conversion from 37 degrees Celsius to Kelvin temperature. Okay, now this equation, this calculation is a little bit straightforward. Remember the conversion between the Kelvin and degree Celsius? That's going to be Kelvin equals to degree Celsius plus 273. You can use 273 or 273.15. I'm using 0.15 here, okay? So again, you treat this one as a constant, okay? So if you plug 37 into this equation, it will give you 37 degrees Celsius plus 273.15. Okay, now if you do the calculation, it will give you 310.15 Kelvin. Okay, as I mentioned a moment ago, you ignore the decimal places of this value since this one has no decimal place. So what we need to do is we just drop the tail. Okay, we drop the tail and we keep the we'll keep the this part. Okay, that will give us 310K. Of course, this is ambiguous because it has an implied decimal point. Therefore, we should use scientific notation. You move the decimal point to your left twice. So that will be 3.10 times 10 to the second Kelvin. Okay, so this is the unit conversion among temperature units. Now let's see more examples. Perform unit conversion, okay, for this one here. Well, how do we set up unit conversion? We saw some, conversions in the previous slide, but here, let me show you how we deal with this unit conversion involving other units. Okay, so remember in this conversion, you need to convert the ounce to gram. Okay, so when you set up the equation, you should let me write it here, 28.9 ounce, okay, times. Now, how do you use this unit conversion factor? Okay, here's the key part. When you use the unit conversion factor, you set up a division like this, and the target unit should be on top. Okay, so target unit is right here. So you should keep the 28.3 gram on top. And the unit you want to cancel, you want to remove, you want to get rid of should be at the bottom. Okay, in this case, 1 ounce should be at the bottom because we want to cancel the ounce. When you have ounce at the bottom, then you can cancel it. Okay, you can cancel it. Now, if you do the calculation, it will give you the answer as 817.87 gram. Okay, the unit you want to keep should be on the top, or the desired unit or target unit should be on top. All right, now again, what the significant figures we're supposed to have? Okay, well, you consider this as a constant. This as a constant. So the answer should have 3 significant figures as this 28.3 ounce has. Okay, so we should have 3 significant figures for the final answer. That will give us 8.18 times 10 to the second gram. Okay, so this is this question. The next question, from yard to meter. Here, this is a unit conversion factor. Again, let's set up the equation. 1342 yard times, okay, for this division equation, the unit you want to keep should be on top. Okay, so this should be on top. 0.914 meter on top and 1 yard at the bottom because you can cancel the yard. And that will give me 1226.588 meter. And let's come up with the significant figures so you can let's use the scientific notation, and so you can keep the right significant figures. You move the decimal place points to your left 3 times. Okay, that will give us 1.22658 times 10 to the third meter. And how many significant figures we're supposed to have? Again, please remember these are constants. Okay, and for this number it's ambiguous, so we can see that this one has 4 significant figures. Therefore, the final answer should have 4 significant figures. That will give us 1.227 times 10 to the third meter. Okay, well, more practice problems. Okay, from inch to millimeter, kilogram to pounds. All right, let's take a look at this conversion. Again, please remember how we use the unit conversion factor. Okay, 1.4 inch. Okay, the unit conversion factor. The unit you want to cancel should be on the bottom. 1 inch. 1 inch here. 25.4 millimeter should be on top. 25.4 millimeter should be on top. Okay, so in this case, you can cancel inch and keep the millimeter. And the calculation result would be 35.56 millimeter. Again, for significant figures, ignore the significant figures of those constants. This one has 2 significant figures. Okay, so therefore, we should keep the significant figures for the final answer. Okay, move the decimal points to your left once. That will give us 3.556 millimeter times 10 to the 1. Oh, sorry. Millimeter should be at the end. Okay, times 10 to the 1 millimeter. Okay, now we consider the significant figures. We're supposed to have 2. You drop this 2, of course, because this is 5, so you need to run it up. Now that will give us 3.6 times 10 to the 1 millimeter. Okay, the last one here, from kilogram to pounds, we do the same thing. 1845 kilogram times, okay, unit conversion factor. We keep the 1 kilogram at the bottom, 2.2 pounds on the top. Okay, so we can cancel the kilogram and keep the pounds. Now the calculation result would be 4059 pound. Okay, we are supposed to have 4 significant figures. You know the significant figures of those 2 constants. Okay, so that will give us, and in addition, we should, this is ambiguous. We should avoid this type of situation. So we need to, let's use the scientific notation first. 4.059. You move the implied decimal point 3 times to your left. That will give us times 10 to the third pound. Now you consider the significant figures. This number has 4 significant figures. It matches with this number. So this is going to be our final answer. All right. Okay. The next slide, let's take a look at some practice problems involving densities. Okay. Density, unit conversion involving density sometimes could be confusing. But again, when you set up the equation, remember what you need to keep, what unit you want to keep, and what unit you want to cancel. Okay, so that's the basic guideline. All right, now remember how we define density. Okay, well, for this question here, you know the the liter. Okay, you know the volume of this the bicycle frame, and you know the mass of this bicycle frame, and it asks you to calculate the density of this frame in gram per cubic centimeter. We all know that the density definition is defined as density equals to mass over volume. In this problem, it particularly asks you the final units of the density should be the gram per cubic centimeter. In other words, when you use mass, the desired unit you want to have is gram on top, and the desired unit for volume should be cubic centimeter. Okay, so this is a mismatch from what we have in the problem. You have volume as a liter. This is different from the desired cubic centimeter. You have mass with the unit as kilogram, and this is gram. So what we need to do is we need to do unit conversion on both top and bottom parts. Okay, so let's do this. All right, let me write it here. So density for this bicycle frame should be, let's do the top part first. We need to convert the kilogram to gram first. Okay, 1.41 kilogram times, well, okay, what's the connection between kilogram and the gram? Okay, if you happen to remember what we learned in the prefix multiplier, lowercase k in this case, lowercase k in this case, that represent 10 to the, let me write it here, okay, let me write it here, that represent 10 to the third gram. In other words, 1 kilogram equals to 10 to the third gram. Okay, so this is what we learned before, and I hope that this is not a surprise for you. Okay, all right, so we got our unit conversion factor. Again, since you want to cancel the kilogram, you should have the kilogram at the bottom, 1 kilogram right here, and then the desired unit gram should be on top, so 10 to the third gram on top. So this is the equation for the mass. How about the volume? The volume, we are given the unit as liter, the 0.314 liter, and then what's the unit conversion factor between liter and the cubic centimeter? Well, if you happen to remember what we had in the discussion of the first topic, units of measurement, we specifically talked about the units of volumes. Okay, so this is required. Okay, 1 liter equals to 1,000 ml and 1,000 cubic centimeter. Okay, so we're going to use this too for this conversion. Okay, liter, you want to cancel, put that at the bottom. 1,000 cubic centimeter on top. Okay. All right, this is the equation. We're finished. Now let's do the calculation. On top, it gives us 1410 gram. Okay, again, we are supposed to have 3 significant figures. So let me highlight the 1 here. And then for the bottom, ignore the significant figures of those constants, and we are supposed to have 3 significant figures. So the bottom part is going to be 314 cubic centimeter. Okay. Now the last step is a division. We should follow the number with the fewest significant figures. This one here, 3 significant figures is supposed to. This one, 3 significant figures. So for the final answer, it's supposed to have 3 significant figures. Okay, so I'll do the calculation. Now it gives me 4.49 gram per cubic centimeter. Okay, so 3 significant figures. This is the final answer. One more problem. This question here, acetone. Density is given. What is the mass for this much of acetone? Okay, now how do we do the calculation? You have mole and you have cubic centimeter. Okay, so how do we cancel the cubic centimeter and reach the final unit or reach the target unit, which is gram? Well, what you need to do is you convert the mole to cubic centimeter and use this as a unit conversion factor, okay, to do the calculation. So let me do it. That's going to be 28.56 mole. You convert mole to cubic centimeter, and we have it right here. Okay, that will give me, well, again, 1,000 mole should be at the bottom, the unit you want to cancel, and 1,000 cubic centimeter should be on top. Okay, the unit you want to keep. Okay, so in this case, you can keep this. You can cancel mole and keep the cubic centimeter. All right, this is not done yet. We need to use this density as a unit conversion factor. How do we do it? Remember, this part will give you the unit as cubic centimeter. So when you use this density as a unit conversion factor, you need to have 1 cubic centimeter at the bottom, okay, and 0.7857 gram at the top. Okay, so in this case, you can cancel the cubic centimeter and reach the final unit as gram. Okay, and if you do the calculation, it will give you 22.44 gram. Okay, significant figures. Why do I keep 4? It's because this one has 4 significant figures. And please remember, ignore the significant figures of this constant. Okay, so that's why I keep 4 significant figures for the final answer. All right, so if you have questions, let me know.